Alright folks, welcome back. I just had a request to come in on working some scientific notation problems, so let's go ahead and get started with this one. In these set of problems it has write the following numbers in the correct scientific notation. There's several different ways to do this, so let's go through them. Remember, in scientific notation you have to have a number basically basically our first rule is you have to have a number in the front of a decimal that is the numbers 1 through 9, meaning you want it to be expressed as like 1.07 times 10 to some power, like to a -4, or to a positive power, so something like 8.23 times 10 to the 6th. Okay, scientific notation just says that you have to have one single digit in front of the decimal, and that one single digit can be the numbers 1 through 9. After that, you may have as many numbers as needed behind the decimal, or actually you can have no numbers behind the decimal. For example, you could have something like 9 times 10 to the 5th. Okay, but usually you're encouraged to put 0.0 here instead of just writing a 9, but sometimes this happens, so if you see it, they're technically not wrong. So but anyway, let's go ahead and work the problem that we have here. Okay. Alright, if you look at significant figures, you'll notice that the most important numbers out of all of these is the 2, the 3, and the 5. And the reason why they're the most important is, according to the sig fig rules, is that they're not zero numbers, meaning they're not placeholders. So placeholders are not significant, hardly ever, unless they're trapped or unless they're behind a decimal with a significant digit in front of it. So basically here, the two most relevant numbers are the 2, the 3, and the 5. They're the most significant. Okay, so what we're going to do is we're going to write 2.35. The reason why I'm putting the point here is that will give me one single digit in front of the decimal, and that's one of the rules for scientific notation, is get one number in front of the decimal that is significant, basically the numbers 1 through 9. Now if you look here, that decimal has made a long journey. It went from being way back here to way up here. So basically it's making a trip from here all the way up to there. Okay, and we need to count how many swings that is. So if you look, that's 1 swing, 2 swings, 3 swings, 4 swings, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 swings, so we will write times 10, and this is going to be to the 12th. Now big numbers are positive. Okay, so this right here itself is a big number. It's a big number. Now what I call big in scientific notation is a number 1 or greater. Okay, that's what I call big. So but now this one is written in the correct number of sig figs. Okay, the other way that you could do this is you could take a TI-83 calculator. Oh, excuse me. Allergies. Alright, you can take a TI-83 calculator, and with the calculator you can actually get it to tell you the answer. All you need to do is type in the number just type in the numbers 2, 3, 5, and if you count the zeros, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so now they're in the calculator. All we have to do is press mode on the calculator, and let's select SCI, which is scientific notation. Move the blue arrow on the right here, move it over 1, press enter, and after that you can press clear and you go back up to the front here. Then you can press enter and it gives you the answer. Now this capital shrunken down or squinched E means times 10. So 2.35 times 10 to the 12th is your answer. Alright, now let's do it for the other one now. Now here, notice that this is what I would call a little number. Okay, it's little. And the reason why it's little is there's not a number in the front here that's a 1, a 2, a 3, a 4, a 5, or a 6. Somewhere in the front, it's not. So this number is little because it's less than the number 1. Okay, so that's how I define it to be small. Now it's the same principle here. You just count the number of swings: 1 swing, 2 swings, 3 swings, 4 swings. That's 5 swings. Okay, now the most important digits here is the 7, the 6, and the 4. Okay, so we're going to write that down: the 7, the 6, and the 4. But where we're going to put the decimal, remember, we can only have one number in the front of our decimal, so we can't put it here or here. We'll have to put it right here. Okay, you're halfway done now. All you got to do now is go times 10, and then remember the number of swings that you had to do. That's 1 swing, 2 swings, 3 swings, 4 swings, 5 swings. So this is a small number, so it's going to be a -5. Now this, what I'm about to show you, is a good way to cheat to get this -5 without counting the swings. You can, as long as they've got a 0 in front of the decimal, just a 0, then you can just count the number of zeros. That's a quick way to hurry up and get the answer. But you got to be careful, because sometimes they'll intentionally put multiple zeros here just so you cannot do that cheating trick. So anyway, it's 1, 2, 3, 4, 5. Okay. Anyway, that's our answer on this problem. Okay, and yes, we're done. Now let's punch it into the calculator just so you can see it. We have 0.0000000. Make sure that's right. 1, 2, 3, 4. Yeah, 5. And 7, 6, 4. Remember, we were already in the scientific notation mode, so we're good on that. So now let's just press enter. Booyah! 7.64 times 10 to the -5. Alright, now let's look at the next one. Now the next one is so close to being correct. It is so close. Now what we need to do is, we honestly just need to move this decimal one more time. Okay, we're going to swing it forward. Okay, so what we're going to get is we're going to get 8.95. Now this times 10 to the 6 is still really there. Okay, all we did is we swung the decimal forward, because this was 89.5. It's not written correctly because there can only be one number in the front of the decimal. So we're going to put the decimal one move forward. So this times the 6 that was originally there is then going to be multiplied again by the one swing that we had to do, which is to the first. That's one swing forward, because 89 was a big number. We moved it forward to make it a little bit smaller by a power of 10. So to count for that, we got to make sure that we add it back into this 6 here. So this answer is going to be 8.95 times 10 to the 7th. Now, to show you that that's correct, let's pull up the TI-83 calculator, and you can type it in just like you see it here. 89.5. Now, to do the times 10 on the calculator, there's a few different ways you can do that. You can punch it in as times 10 and then raise it to the power of 6, and this calculator will correctly put it in the correct number of powers of 10 for you. So watch. Notice it went 8.95 E7. Now, if you want to punch it in without having to type in times 10 to a power, and just use that little E like they have, then you can punch it in like this. You can take their original number, 89.5, and to do times 10, all you got to do is hit second, comma, and then put the 6 after it and press enter and let the calculator do the work for you. Okay, this is time and convenience and less frustration for some of you. Okay, now that's the answer on C. Now let's look at this last one down here, D. We've got 234 times 10 to the negative 12. Now, you can already tell that the decimal is not there. Now, where does the decimal really need to be? It really needs to be between the 2 and the 3. Well, if you look, that took one swing, 2 swings. That took 2 swings. So that is a movement of twice forward. So what we're going to do is we're going to hit times 10. Now, is this going to be to the negative 2 or is this going to be to the positive 2? Now look at the number again. It was 234 and we've made it the number 2.34. Okay, that is basically scaling it by a multiple of 10 twice, by powers of 10 twice. So we're going to say that that's a positive 2. Okay, now to write this correctly, all you need to do is write 2.34 times 10 to the negative 10, because remember, this is negative 12 plus 2, so we're still in the hole by 10. Okay, now to check yourself on the calculator once again, get your TI-83, punch in the numbers that they've given you, which is 234, and then hit times 10 or second comma e to the negative, there's the negative sign, 12. Okay, press enter and notice that we get 2.34 times 10 to the negative 10. Alright guys, I hope this was helpful over this scientific notation exercise that someone requested, and y'all have a great day. Alright.